Given that z equals to root 3 minus I, write z in the form r e to the I theta in polar form. This complex number, z equals root 3 minus I, has real part equal to root 3 and imaginary part equal to minus 1. On an Argand diagram, this complex number would be more or less in a position in this Argand diagram, 3 real minus 1 imaginary. So it'd be here, the complex number z. The modulus is the length, well, here is 3. Modulus is the length of this line. The argument is this angle. We could use trigonometry to find this, Pythagoras, but rather than doing that, we're going to use the calculators. In the Casio calculator, we just get the number root 3 minus I, and then we use the option button to select complex, and then select this option to change to a modulus argument form. Then it becomes this. This is the modulus. 2 is the modulus. It's the length of the line from the origin to point Z. And minus pi over 6 is the angle. So all you have to do is to copy this from the calculator. So the complex number Z can be written as 2e to the minus pi over 6I. In the Texas calculator, you can do root 3 minus I. And then after doing this, you go to math, and then you select complex, and then polar form, number 7. And then it's going to change the number to the form. But then in this case, since my calculator is in degrees, the angle is in degrees, 30 degrees. 30 degrees is an angle that we know that is pi over 6 in radians. So it could be used in the same, but the calculator does not give the answer in terms of pi, if the calculator is in radians. Now to do part B, we want to find the imaginary part of z1 plus z2 in this form. We have to do is to add the two complex numbers, the two functions of t, e to the 2ti plus 2e to the 2t minus pi over 6i. This is z1 plus z2, in fact. z1 plus z2. Then we are going to expand this part, this complex number z2, so that we have e to the 2ti as a common factor. So it's going to be e to the 2ti plus 2e 2ti minus pi over 6i. This is the exponent, which can be written as 2e to the 2ti times e to the minus pi over 6i. Now, writing to e to the 2ti as a common factor, 2ti, 1 plus 2e to the minus pi over 6i. This part, we take the calculator to find this for us. In the Casio calculator, we do 2 plus 1 plus 2 e to the power of minus pi over 6 I, pi over 6i. And then this is in rectangular form. We change to modulus argument, and this becomes this number. So 2.90 and argument minus 351 to 3 significant figures, e to the 2ti times, that needs to be written as 2.91 e to the minus 0.351 I. And then finally, this is 2.91 e to the power of 2ti minus 0.351 351i. 351i. And again, writing I as a common factor, 2t minus 0.351i. This is z1 plus z2. The imaginary part of this complex number is just writing this and taking the part with sign. So the imaginary part of z1 plus z2 is just 2.91 sine of 2t minus 0.351. That's it.